Welcome back to Kubernetes Crashcasts. I'm Sheila, and I'm here with Victor to dive deeper into the world of Kubernetes. Before we begin, if you're enjoying our podcast, please take a moment to rate us on your favorite podcast platform. Your support means the world to us.
Thanks, Sheila. Today we're continuing our journey through the Understanding Kubernetes Architecture chapter. We'll be exploring the concept of master and worker nodes, which is fundamental to how Kubernetes operates.
That's right, Victor. But before we dive in, I have a quiz question for our listeners. Here it is. In a Kubernetes cluster, which type of node is responsible for maintaining the desired state of the cluster?
Ooh, that's a great question, Sheila. It really gets to the heart of how Kubernetes manages workloads. Listeners, think about the different roles you might have in a system. Who's giving orders and who's carrying them out? Keep that in mind as we discuss the topic, and we'll reveal the answer at the end of the episode.
Perfect. Now let's start with the basics. Victor, could you give us a high-level overview of what master and worker nodes are in Kubernetes?
Certainly. At its core, Kubernetes uses a distributed system architecture with two main types of nodes: master nodes and worker nodes. Think of it like a company structure. You have managers, master nodes, who make decisions and delegate tasks, and you have employees, worker nodes, who actually perform the work.
That's a great analogy. So, if I understand correctly, the master nodes are like the brain of the operation, and the worker nodes are like the muscles.
Exactly, Sheila. The master nodes are responsible for the overall management of the cluster. They make global decisions about the cluster and detect and respond to cluster events. Worker nodes, on the other hand, are where the actual containerized applications run.
I see. Can you tell us more about the components that make up a master node?
Of course. The master node consists of several key components. The most important one is the API server, which acts as the front end for the Kubernetes control plane. It exposes the Kubernetes API, which is used by both external users and internal components to communicate with the cluster.
Interesting. What are some of the other components?
Great question. We also have etcd, which is a distributed key-value store that acts as the cluster's database, storing all cluster data. Think of it as a highly reliable notepad for the cluster. Then there's the scheduler, which assigns workloads to nodes based on resource availability and other constraints. Finally, we have the controller manager, which runs controller processes that regulate the state of the cluster.
Wow, that's quite a lot to take in. It seems like the master node has a lot of responsibilities. What about the worker nodes? What components do they have?
You're right, the master node does have a lot of responsibilities. Worker nodes are a bit simpler. They have three main components: the kubelay, which is the primary node agent that communicates with the API server and manages containers on the node; kubeproxy, which maintains network rules on the node; and the container runtime, like Docker or Containered, which is responsible for running the containers.
I think I'm starting to get it. So the master node tells the worker nodes what to do, and the worker nodes actually run the applications. Is that correct?
That's a great summary, Sheila. The master node doesn't directly tell the worker nodes what to do, but it sets the desired state of the cluster. The components on the worker nodes then work to achieve and maintain that state.
Ah, I see. That makes sense. Are there any common misunderstandings or pitfalls people often encounter when working with this architecture?
Definitely. One common misunderstanding is thinking that the master node directly controls every action on the worker nodes. In reality, it's more of a declarative system. The master node declares what the cluster should look like, and the worker nodes figure out how to make that happen.
That's a crucial distinction. Are there any best practices or tips you can share for managing master and worker nodes?
Absolutely. One key best practice is to always have multiple master nodes in production environments for high availability. It's also important to regularly update and patch both master and worker nodes to ensure security and stability. And don't forget about monitoring. Keeping an eye on the health of all your nodes is crucial for maintaining a robust cluster.
Those are great tips, Victor. Now, I'm curious, how does this architecture compare to other container orchestration systems?
That's an excellent question. While the master worker architecture is quite common in distributed systems, Kubernetes has some unique aspects. For example, compared to Docker Swarm, Kubernetes has a more complex but also more flexible architecture. This allows for greater scalability and more advanced features, but it can also have a steeper learning curve.
Interesting. It seems like the complexity of Kubernetes really pays off in terms of flexibility and scalability. Now, before we wrap up, let's reveal the answer to our quiz question. Victor, would you like to do the honors?
Certainly. The answer to our quiz question is, the master node is responsible for maintaining the desired state of the cluster. It's the master node's job to ensure that the actual state of the cluster matches the desired state, delegating tasks to the worker nodes as necessary.
Thank you, Victor. To summarize what we've learned today, Kubernetes uses a master worker node architecture. Master nodes manage the cluster, making decisions and maintaining the desired state, while worker nodes run the actual containerized applications. The master node includes components like the API server, etcd, scheduler, and controller manager, while worker nodes have the kubelay, kubeproxy, and container runtime.
That's a great summary, Sheila. Understanding this architecture is crucial for anyone working with Kubernetes, as it forms the foundation for how the entire system operates.
Absolutely. And to our listeners, if you found this episode helpful, please visit crashcasts.com and consider joining our Discord community. Your support on Patreon helps us continue creating these educational episodes. Don't forget to subscribe and rate our podcast. It really helps us reach more people who can benefit from this knowledge. Thank you for listening, and we'll see you in the next episode.